Hi everyone and hello, welcome to this video. So last time we did our skybox. Now it's time to start working on our terrain, and for that we're going to need a bit of physics. Well, actually no, we could render our terrain without any physics, but I just want to have physics here as well. So this video, we're not going to write physics from scratch. I'm not sure if it makes sense for this tutorial series. What we're going to do is use physics engine, and there are a couple of physics engines, and one that we're going to use is called Bullet. The other popular one is NVIDIA Physics, I guess, as open source, and then you have like commercial ones like Havoc, etc. So for the Bullet Sharp, we just need to install it as a package, so we can do it right now, and then we can start playing with it and creating our scene. So if we just go to Manage NuGet Packages, and here it's offering something, and if we search for Bullet, then there is Bullet Sharp, and we're going to use that one. It hasn't been updated for a while, but it actually works pretty well. So let's use that one. I think it's going to be fine. And then we can start working on it, but first of all, we're just going to create a new scene, which I'm going to call terrain scene. And as usual, we just copy some stuff over. So I'm just going to copy this over and then rename it to terrain. So this is fine. I'm just missing here closing, and this is called Skybox. So I'm going to rename it to terrain scene. We can add it to our program. And for the next couple of videos, I guess we're going to be working mostly on this terrain scene. But let's get started with it. And the first thing, we're just going to create a new folder, and I'm going to call it game objects. And I just want to clean up the terrain scene from the game objects. So I guess we can move out Skybox to a game object. So that can be a game object. And then further, I guess we can create a cube game object as well. So let's get started with that actually. So idea is I just want to clean up some stuff before we start working on some other stuff. So I'm just going to copy this and then create a new class. I'm just going to call it simply Skybox object. We're going to need this. So that's fine. We can leave that as is. And then further, we're probably going to need the initialize method, and then we can create this cube texture, and then take the skybox as well, all the properties related to our skybox. So if I just go here, we're going to have public void initialize, and we can pass data that we need. So in our case, it's going to be engine. We can move it there. We need that render pipeline, so let's just go to our terrain scene and fetch the pipeline as well now. And then we can just say public void render skybox pipeline render, and we need the camera information as well, so let's just paste that in as well. As you can see, actually, even with somewhat bad coding and not paying too much attention to like code format, it's actually really fine. This was easy to refactor, so it's not that bad. So let's go to our terrain scene, and here let's just see if that works. So what did I call it? I called it Skybox object. Skybox, we just need to create it, initialize it. So I can just create it here because most of the code is initialized. So we can just hit initialize, right? And then here we could say skybox.render. So this is not relevant though, it's just rotation. I don't find it that important. And we had our program, right? Terrain scene, it's there. Let's try it. Let's give it a shot. Let's see if it works. It's another screen, but it does work, right? We still have our skybox. So our cube is not rotating, so it means that the scene is correct. All right, so let's go a bit further. Next thing that I want to clean up is just this, where are you? Cube. I guess that can be object as well. So I'm going to call it crate, maybe, because it's kind of crate because of the texture. So I'm just going to go with it, create game object. And I called it object here instead of game object. So yeah, let's just call it crate. We can push them here, and then I'm going to rename this to Skybox as well. No reason to prefix everything with object, or to suffix everything with object. So let's work on our crate here. So we just go to our terrain scene. So we're going to need vertex index buffer, our texture, and our pipeline. I guess that's it. So we just need to move that over. If I could find it here. So we need to move this over. We need to initialize. Engine. So it might not be a bad idea to paste it maybe here, actually in constructor. And still have initialized because of this here, right? So maybe we can do that for Skybox as well. The camera is initialized a bit later, so I'm going to leave it here. So yeah, it could use some refactoring, but it's not really relevant for this video, so I'm going to leave that to you. Then in our terrain scene, we need to fetch only render pipeline, texture, right, and buffer. So basically all of this. So now our Skybox gets engine, right? So let's just fix it real quick. And I copy this over, so it's not create, it's actually crate. Okay, texture we don't have, so I need to fetch that as well. Rotation is not relevant here, so just some cleaning up. Texture is relevant here though, so we just need our camera, so we're going to inject it here. Go back to our terrain scene, see what we need further. So this image we don't need anymore. I guess we can assume that our image loading is fine. So render, this belongs to crate now, and this, do we need these groups? I guess no, I'm just going to say here terrain scene so that we know if there is something else, but it's really not relevant. And then our crate. I think here, quite render, right? Cool. And then we can just initialize it by default to be somewhere else, right? So we could say something like, sorry, not create, only render pipeline. That's our pipeline, transform. And then we can create random, new random, right? Matrix 4x4 dot create translation. So we can say random rand dot make single and 10 times 10, and we can do similar for Y and Z, I guess. So we just want to have random crates. And we can center it around the screen, but just subtracting by 5, right? Then it's going to be from -5 to 5, depending on random. So we can do this. And that's okay. Going back to our terrain scene. So we need those crates, but now we can have a list of crates. And we can initialize number them, so let's add roughly 20 of them, right? edit new crate, but let's not do it like this because we still need to initialize it. So I'm going to say like this. We need engine and then camera, and we still need to initialize it, right? And then we can render them as well. For each creating crates, create render. And we need to clean this up. So I can do it here. So I'm just going to make it have a disposable. And then we can dispose of the stuff here. So we should probably do that for Skybox as well. Let's just test this out. And as you can see, we have a bunch of crates here. Some are overlapping, that's fine, because with the physics, actually we want to model gravity for them, so they're going to fall up. They're going to fall down, and then the physics engine is going to do everything, and they're going to move around and stuff. Not relevant yet. So while at it, let's also clean up here resources, so we can do this. Implement interface. So we need to dispose of what here? Skybox texture, right? And Skybox texture dispose. And that's quite alright. I'm just going to move it here. Okay, cool. So finally, we come to the step where we can use the physics engine, and I'm going to explain it as I go because there is some steps with the setup. It's not that hard, it's actually really easy, and then we can just start adding it. So now that we have our physics engine, so I was thinking of making it part of an engine, but I would leave that to you. So I'm not going to make it part of the engine. Should I? Probably not for now. I would say you can always refactor in the future, because I just don't want to waste like your time with stuff that's actually just refactoring. So this is just example, and we can think of it like that. And for the engine, we just create, sorry, for the physics, we just create something called world, and here this discrete dynamic world. So we're just going to create a world, right? And then we're going to have to initialize a bunch of stuffs, and these are just managers for the bullet. So dispatcher is responsible for collisions, so we can paste here. So documentation is really sparse, so you probably need to have trouble finding documentation for it, especially in C#, right? Because there is no C# documentation for bullets, so you have to look at C++ examples, but so yeah, I didn't find too many, so you just kind of have to play with it and try to figure it out. It's not that bad. Once you set it up, it's actually really easy. Then we have this broad phase, so it's kind of responsible for, it's a bit complicated, but for collisions as well, I guess. And then the constraints resolver, it actually is responsible for resolving constraints if there are any. And then we just have default collision configuration, and that's actually it. So we basically have our engine created for the physics. So we just need to pass it around as usual. So our terrain scene, I guess we can pass it in. So we can just say here world, and then in our terrain scene we can actually create it. So we're just going to paste it in. We can say world. And then we need to pass it to our crate, right? So like this, actually like this. Let's go to our crate, and then we need to paste that world in. Okay, and then let me see my notes a bit. Okay, we just need to create rigid body for it, and the body is kind of representation of basically our body, right, in physics world. So we can do just that. So here I'm just going to physics, I don't know how to name this, but we can just create collision shape. And if you remember correctly, so now the thing is, we kind of need to match units, right? What our graphics does with our physics. And the box shape, if you look at here at documentation, it says I should have done this. It says box half as length, so it's a half a unit. We represent our crates, if you remember, by 1 unit. So here it's going to be half of our unit. So if your box was 2 in size in a world, you would actually pass here half of that, so you would pass 1, right? Okay, so we need to create something called motion state. And I guess we can talk more about physics as we go a bit further. But for now, yeah, so this is kind of tricky, right? Because our matrices are not the same. So here, if we take a look at this, it takes matrix, right? But we use silk.net matrix. We use basically, it says something like matrix 4D type of float, right? If you remember. So if we check type here, exactly this. So we just need to translate this matrix to something that this takes. And here I actually prepared something, but I totally forgot about it. So we're just going to create this class, and I'm going to call it matrix extensions. So, and then I'm just going to copy something, and I'm going to leave this in the description of the video, so don't type this. It's basically just copying, like row by row, column by column, the matrices. So basically we have the bullet matrix, right? From our silk.net matrix, and then the other way around. So don't worry about it. I'm going to leave it in the description of the video. Just copy this and you're done with it. Then further. So now we have that. Where were we? Our crate. So we can just place origin here, I guess, from our unlight render pipeline transform to bullet matrix, right? So that's our starting transform matrix. Then let me see. So a lot of notes here because all of this physics is not that familiar to me. So basically we can just create a rigid body construction, right? So this is just the info for our rigid body that we're going to create. And here it's set float mass. So we can set mass here as a property. So I'm just going to set it to 1 by default. So if it's 0, it's not going to move in physics world. So you just kind of have to need mass, and I would say the mass, it's probably best to model it after real world. So crate would be something like maybe 20 kilos, I don't know, but I'm just going to use 1 for now. It's not super relevant. So it's going to have moon-like physics, I guess. But we can just place mass here, and then motion state, and then shape, right? The shape is shape of our body in physics world. And for the next video, you're going to see, because we're going to write debugger in WebGPU to debug actually the physics, but not for this video. For this, it's not relevant yet. It's going to be in future. So we have something, we just have to set something called local inertia. Maybe not even. Do we need to set it from our mass? I think we do. And now finally we can create a rigid body, and rigid body is actually going to be here. Right, and then we can set it right over here. Can paste that construction, and then finally we just need to edit to world, right? And that's how we add this physics body that we have created, right? All of this is just set up for our rigid body, right? And I do recommend that you play with all of these properties to understand it a bit better. But then we add it to our world, and finally we're going to need new method, which I'm going to call public void update. So only thing that we need to do here is get that world transform matrix. So we basically get bullet matrix, right? So maybe it will recognize it. It's here using bullet sharp.mat. Okay, it's matrix, right? We get the matrix here, and then we just say our pipeline. And I called it here only train the pipeline. I'm going to rename it. It's really pipeline. Our pipeline dot transform is transform, and then we have to use this to self.net matrix. And now if I run it, nothing is going to happen because I never called update for start. And so if we go to our terrain scene, so we just need to say for each crate, in crates, right, update. And nothing is happening because I forgot one very important step here, and that's to update our world. So here, update after, let's do it after keyboard inputs, world.step simulation. And here we could use delta time. We're just going to assume that we're running at 60 frames per second and then step simulation like that. I believe we are running at 60 frames per second. It's going to take a while before we get any performance hits that are significant. So I guess this is fine without delta time. So let's try it now. And if you take a look at here, you can see cubes falling. So obviously we just want to place some terrain here so that they fall on something and just don't fall through the scene. So let's go with that. And here what I want to do is just start preparing our terrain object. We're going to be working with it quite a lot in the future. But for now we're just going to set up some simple terrain. So it's going to be very similar to our crate object. So I'm just going to copy most of it because there is almost no difference here. So what I'm going to say here, this is fine. So we just need our engine, right? And then what was this called? Dynamic world discrete, right? This world, and then we can pass our world in. So our mass is going to be 0 here. So yeah, we're not going to even add that property anywhere because we're just going to hardcode it at 0. Right here and right here. Transform. So here, I don't care about it. So let me just see, maybe I have some tips. We don't care about this. It's always going to be identity at the center. Right? And now box shape is kind of important because we need to shape our terrain. So I guess we could go with 5, then 0.5 and 5. So that's going to create, you're going to see. So we just want it to go to have some width, large length, right? And then the height is just, it can be very thin terrain. I'm just using 0.5 so that our collision is not very thin, if you know what I mean. Okay, so we have our info, motion state, rigid body. That's quite alright. We don't actually need local inertia, right? For sure now. This is alright. And pipeline transform, let's do it actually here because we don't need to update it, right? We're not going to move our terrain around. So we can just do it like this. And if you remember, I said here we'll need 10 units, but this is translation. So we just need to create scale. So since these are half units, we just need double of that. So we need basically 10, 1 and 10. And it's just complaining because it doesn't know that it's float. It must be float, so we can do it like that. And then, yeah, that's fine. And they're both going to be around the origin. So both our WebGPU, right, our graphics, and our physics are going to be at the origin. So we don't actually need to do this, and update step is not important here. So we can just clean that up, and then we have pipeline render. That's fine, everything's fine. Yeah, we can probably get rid of texture, but let's just try it out. Let's see what's going to happen. So let's just create terrain here. Terrain. We can just initialize it here. And then we can write up the skybox. It's probably a good place as any. Initialize. So we just need our camera information, and then we can render it somewhere over here. So let's give it a shot to see what's going to happen. So we're almost there. Oh, actually we are there. As you can see, our terrain is being rendered as a huge cube. It's not important for now. It's okay. But yeah, we can leave it at that. So let's just try once more. Let's go to our crates. So I just want them to be higher, because right now it's just they fall too fast. So I'm just going to do it times 50 in Y, and then we can add some offset. So it's just going to break this into a couple of lines. And if we try it now, so going here, okay, that's good. That's good. I just want to create more of them. Let's go to our terrain scene and let's create 100 of cubes. Let's see now. As you can see, it works beautifully. So yeah, that's it actually kind of for this video. I didn't want to do any WebGPU stuff here and just focus on physics. But as you can see, adding physics is really easy. So this is not physics game engine series, so I'm not going to waste too much time here, but I just wanted to have something because we need to work on terrain in our game finally. So next time we're going to start with the terrain, I guess rendering, maybe split maps or height maps. We're going to see, but yeah, that's going to be topic for the next video. And then when we finish with terrain, we just want those cubes falling on terrain, and then we can work on other game objects and our controller, I guess, our player. So yeah, that's kind of it for this video. Hopefully you enjoyed it. Hopefully you have seen something new, and that it's not that hard to add physics to our small game engine example. Yeah, that's it. Yeah, if you like the video, please like, subscribe, maybe leave a comment, and until next time.